Hi everyone, it's Shiv Shetty with Shiv Solution. This is the video may the troubleshooter of your math phobia. If you feel it's worth of watching, please hit like and subscribe to our channel. Well dear students, let's start this video with addition of vectors. Vector addition. Okay, so to get the idea about the vector addition, let me take a scenario. So here is a scenario that imagine a person or a man moves from particular place. Imagine a man moves from place A to place B and then from there he moves to place C. Okay, a man started his journey from place A and then finally he ended with the point or place C. Okay, now the question is, what is the net displacement done by that person? What is the net displacement done by that person? So the net displacement done by that person is vector AC. We call it as a vector AC, correct? So this can be expressed as vector AC is equal to means the net displacement done by that person. We'll get this as by adding vector AB plus vector BC, and this we call it as a triangle of addition. This is the way we are going to add the vectors. So the question is here, can we add whatever way we want? No. These students, we can't add the vectors whatever way we want. There is one rule. So the rule to add the vector addition. Rule to add the vectors. Okay. So what's the rule? Simple, yes. To add any two vectors, let me get a diagram. Then we get the idea. Let me take here vector A and vector B as two vectors. There are two vectors, vector A and vector B. Okay, so vector A and vector B, both they are with 2 points. One is initial point and another one is terminal point. Will you agree with me? So this is initial point of vector A and terminal point of vector A. So along with vector B also has the initial point of vector B and terminal point of vector B. Now I need to add these two vectors. I need to add here vector A and vector B. So to add these two vector A and vector B, please keep in your mind we have to position these two vectors. We have to position these two vectors in such a way that the initial point of vector B need to coincide the terminal point of vector A, or initial point of vector A need to coincide with terminal point vector B. So whatever way, so what way you want, you need to add that way. That means if you add any two vectors, here the compulsory that the initial point of one vector need to coincide with the terminal point of another vector. Then only you are able to add two vectors. So then when I add two vectors, now see here, come to this diagram. Here vector AB is initial point this one and terminal point is this one, and vector BC is this is the initial point and this is the terminal point. Then when I add these two vectors, so let me take AB as vector A and BC as vector B, correct? So when I add these two vectors, my resultant vector will be vector AC, or you can also call it as a vector A plus vector B. Vector A plus vector B. Okay, so now my question is, I think I can take vector AC as a minus of vector CA. Because both they are with the same vectors except its direction. Only the direction changes, but both they are the same vectors. Correct? That means the direction is opposite to each other. So I can take here vector AC as a minus of vector CA. Then substitute this minus CA to place of vector AC. So minus vector CA is equal to vector AB plus vector BC. Then when I solve this, when I simplify this, I get here vector AB plus vector BC plus vector CA. This is in the third diagram. I'll go to that. Okay, so I'll be getting vector AB plus vector BC plus vector CA is equal to vector A to A. That means the person from here he started, A to B he traveled, B to C he traveled, and next finally C to A he traveled. That means the net displacement done by that person, the resultant will be 0, because from where he started and he ended with the same point. Correct? So here initial and terminal both coincide each other, therefore the resultant will get the 0. So this Let me conclude with this. See, this implies that when you take the sides of a triangle, when you take the, so please compare this I'm telling now. When you take the sides of a triangle in order, when you take the sides of triangle in order, it leaves the zero vector. It leaves the zero vector. Resultant will be getting zero vector. That because here initial point and terminal point both will be coincide each other. This is the reason we get here zero vector. So please keep in your mind when you take the sides of a triangle. See, have a look at the diagram. When you take the sides of a triangle, it's vector A, it's vector B, and again is moving from C to A. Correct. So in this diagram we get idea. So when you take the sides of a triangle in order, we get the resultant 0. Okay, now suppose a man, as already have taken a scenario, that a man moves from A to B, then from B to C. Suppose instead of moving B to C, if he moves to B to C dash, where both are the same magnitude, okay? Instead of moving B to C, if he travels from B to C dash, whereas C dash and BC both are the same magnitude, then what will be the resultant vector? Apply the triangle law of addition here. Okay, so here BC dash is nothing but equal to vector BC except its direction. It has the opposite direction. That means I am going to take here BC dash is equal to minus of vector BC, correct? So now apply the triangle law of addition to this triangle. A, B, C dash, A, B, C dash. So what do we get here? AC dash is equal to, AC dash is equal to, we're getting AB plus BC dash. So AB is nothing but vector A plus BC dash is nothing but vector minus B. That means I got vector AC dash is equal to, I got here vector AC dash is equal to vector A minus vector B. So this we call it as a difference of vector A and vector B. That is here AC dash. Vector AC dash represent the difference of vector A and vector B. Let's move to the next concept, that is parallelogram law of vector addition. Parallelogram law of vector addition. So what is this parallelogram law of vector addition? We have completed now triangle law of vector addition. Now we are going to the parallelogram law of vector addition. Okay, let me continue this with the diagram. So let me take two adjacent sides of the parallelogram, vector A and vector B. Let me take two adjacent sides of a parallelogram in a magnitude and direction. Now, if I add that two vectors, if I add these two vectors, what will be my resultant? What will be my resultant? Okay, keep in your mind, if I add these two vectors, if I add any two adjacent sides of a parallelogram, I will be that side, the resultant vector in magnitude and direction represented by its diagonal. So keep in your mind again, I'm telling you, when we add any two adjacent sides of a parallelogram, that results the diagonal of a, or that represented by diagonals of a parallelogram in a magnitude and direction. So this we call it as a triangle law of parallelogram. This we call it as a triangle of parallelogram law of vector addition. We call it as a parallelogram law of vector addition. So how we call it as a, how can we done this one? So to get this one, we need here help of triangle law of addition. Let us apply the triangle law of addition. So now dear students, we know opposite sides of a parallelograms are equal to each other, correct? So now this is vector B, means obviously we get this also as a vector B only. Now we got OAC as a one triangle. Apply the triangle law of addition to this triangle OAC. So when you apply that, we get here OC. Vector OC is equal to vector OA plus vector AC, correct? So here OA means we know that is vector A and AC means we know that vector B. So finally I got vector OC is nothing but vector A plus vector B. So this is the diagonal of a parallelogram. So when you add any two adjacent sides of a parallelogram, will be resulted by the diagonal of its parallelogram. Similarly, we get that if you add in triangle OBC, if you apply the same rule, we'll be getting finally vector A plus vector B as its diagonal. Okay, there are some properties for the addition of vectors. There are some properties. So these properties you have studied in the primary, since it started from the primary section. So the properties are like this. commutative, associative, additive, still are there. We'll go for that. So I hope you all heard these properties. Even in the primary section you have heard, high school, yes, continuous it comes. But these are the property what you have studied related to number system, correct? So now let us check it out whether vectors will satisfy these properties or not. Vectors will satisfy these properties or not. Okay. So let's start with the first property, that is commutative property. So what is commutative property? So commutative property is nothing but, see, the students, let me make you fast. 3 plus number system. I am taking the number system. Okay, 3 plus 4 is equal to 7. Correct. So what about 4 plus 3? No doubt, this is also equal to 7. So that means when you add any two numbers by changing its position, the result will not get changed. The result will not get changed. The result remains same. Correct? The same thing even in the vector also. So when you add any two vectors, vector A and vector B or whatever, okay. When you add any two vectors by changing its position, or by changing its order, the resultant vector will not get changed. It will be result the same things only. So that's the reason we call vector addition will satisfy the commutative property, or commutative property exists even in the vector addition. Okay. So then what about the associative property? So associative property, when you add any three vectors by changing its group, the resultant vector also again remains same. The resultant vector remains, I mean, see, here I am making A plus B as one group, then after I am adding C. Here B plus C as one group, then after I am adding to vector E. So the both vectors, the resultant of the both vectors will be remain same. That's the reason we call it as associative property will exist in the vector addition. Then what about the additive identity? So additive identity. So additive identity is one thing. The students, we go back again the number system. 5. I'm adding one number to this one. I need to get the output as a 5 only. So then which number I need to add to get the same as the output? Yes, obviously I need to add a 0. Same thing we are going to do in the vector addition also. That is, the here we call 0 is the additive identity of the number system, correct? In the 0 is the additive identity. Here, then which is the additive identity in the vector? So dear students, to get a vector itself as a result, when you add some vector to that number, that's one and only, that is 0 vector we need to add. So when you add 0 vector to the any given vectors, will be the resultant will be the same vector itself. So we call 0 vector is the additive identity vector. 0 vector is the additive identity vector. So next, multiplication of a vector by scalar. Multiplication of a vector by scalar. So what scalar means already we know. That is a number. Scalar is nothing but it's one number. Okay. Imagine vector A is one number. If I multiply this with 5, then I'll be getting new vector. Here, vector A is one vector. So vector. Okay. I'll be multiplied this with one scalar. One number. I'll be multiplied a vector by a number. Then my new vector will be this one. Now my resultant vector will be this one. Got it? Okay. So the same thing I'm studying here. So let vector A be any one vector. When you multiply this with one scalar number, then we'll be getting new vector, that is lambda into vector A. We'll be getting new vector, that is lambda into vector A. And that new vector will be, can go to the same direction or may go to the opposite direction. It depends on the number sign which you multiplied, either positive number or negative number. So whatever it is, the direction may get same or opposite direction, and the magnitude will get changed, but these will be parallel to each other. Keep in your mind that new resultant vector, the resultant vector will be parallel to our old vector. Okay, so that means if it is 3 meter, if you multiply by this 9 or 2, then we will be getting 6 meter. If you multiply this with minus 2, then we will be getting minus 6 meter. Okay, that means this will be parallel to each other. You can call it as a parallel to collinear vector also. Okay, so lambda into vector A is also vector which has the direction same or opposite. Keep in mind, you may get here in the direction which is same or opposite the old vector. So this is the way we find its magnitude. The magnitude of vector lambda A is nothing but magnitude of lambda into magnitude of vector A. And that geometrically, please have a look at this diagram. So this is vector vector A, this is vector A, and that vector A is multiplied with, here that vector A is multiplied with 1 by 2 means half of that. So when you multiply this half, it will become exactly half. And if you multiply with the 2, this will become double. When you multiply with minus half, then it will become opposite direction. Half of its opposite direction. So, but whatever it is all will be parallel to each other. This is the way we do the multiplication of a vector by scalar, one constant number. Multiplication of a vector by one constant number. Okay. Now, additive inverse. Let's move to additive inverse. So, what is that additive inverse? Here again, same thing, dear students, which we have studied in the primary or high school section related to the number system. That is, when you add two numbers, do we need to get output? See, let me take here 3. I need to add one number to this to get output as a additive identity. That means 0. Then which number I need to add here to get output as 0? That is inverse of this minus 3. Correct? Negative of the given number if you add, you will be getting result as 0. Correct? The same thing here also. I need to get the 0 vector as an output when I add the two vectors. So let A be the any given vectors, then I need to find out the 0 vector as the output. Then which number I need to add to this one? Same vector you add but with opposite direction. Let me add same vector, but it's in the opposite direction. If I add, then I'll be getting, or this will be result as a 0 vector. That we call it as the additive inverse of the given vector. Additive inverse of the given vector means if you want to write the additive inverse for the given vector, just check its opposite direction. That will be the vector which is inverse for given vector.